Now, in the architectural model of distributed system, we have many models. Uh, Client-server model is one of the fundamental model of the architectural model of the distributed system, uh, because it is able to deal all the problems which are associated with the distribution. And it also, this model also describes that how the computational process, what will be the behavior of the services which will be provided to the user, as well as it also allows to design the system as well as the application software for in the distributed computing environment. Now, in this particular model, we have two processes. One is server, another is client. Client sends a request and the services are provided by the server. Function of the server is to perform the all the requested services which is asked by the client and send back the response. The response may be the result, processing result. It may be the confirmation of the completion of the task, or it may be the failure notice which of a particular operation which it has to go do, which it has to do, which it has to send to the user or the client. Now there are many services which is being provided by the server. For the user point of view, you can say it may be the services of mail service, file service, database service, computational service, whatever service is required, it is being handled by the server itself. We have also discussed that we have three components of the client server model. One is service, which is a software entity that runs on either one machine or many machine. And it also provides an abstraction on this well-defined operation in the form of a response as per the applicant's request. Second one is server, which is providing particular service running on a single machine, single system. And the client exploits the services provided by the server by making a request. The important features as far as the client server model is concerned, it is the simplicity. Simplicity means that the way the data is going to flow, the way the control is, we are going to control the flow. It is being done in a very simple manner. The second feature is the modularity, which can be achieved by, which is normally achieved by organizing as well as interacting the many computers, group of computer operations into a separate service mode. Now, as far as the distributed computing system is concerned, whenever it has to be developed based on this client server model, the third important property is the extensibility. By adding extensibility means by able to add some more services as per the requirement. And the last one is the flexibility with the help of the interfaces which will be provided in between the client as well as the server. So besides having all kinds of effectiveness provided by the client server model, we have certain issues or the problems which are related with the client server model. The first is we know that the control is concerned, control of the individual resources are concerned. It is centralized to the single server. इसका मतलब ये हुआ कि the computer which is supporting the server, if it fails, then the element of the control is also going to fail. So, and this is not tolerable. this should be avoided because the operation of the server is very critical, uh, because it is providing services such as file server, or it may be authentication server. So as far as the reliability and the availability of the operation is concerned, it depends on the if we are able to provide multiple servers uh, as a product of reliability. As far as the computers are concerned, devices are concerned, as well as communication lines are concerned, communication channels are concerned. The second problem is that if we are using only single server, that will be a bottleneck because and just to avoid this, what we do, more and more computers are added into the system to work as a server, so that it should always give uninterrupted services. And the third problem arises when the multiple implementation of the similar functions are being used, and it are being used to improve the performance, but because we have to maintain consistency also. So of course it is going to increase the cost, but this is the uh, this is very fair to provide uh, this implementation. So this is about the client server model. The second architectural model is the variation which is being proposed in the basic model, which is the client server model which we are looking for, which we are discussing. And before we go into the detail, let us first discuss that what are the functions of the distributed system, computing system. Uh, the purpose and the goal is to improve the performance by doing the parallel execution of the program on the different workstations, as well as we want also to decrease the response time of the database through the data replication, as well as we want also the support of the synchronous distant meeting. People are distant away, so we also want the same. Support, there are many people who are working all together. We also want to uh, avoid that, so that people working in a group should be free enough to communicate each other and cooperate each other. And uh, by introducing distributed system, we want to increase the reliability also. And how the reliability can be increased? It can be increased by uh, uh, service multiplication, providing same services by many resources. So to perform all these functions, many servers must be available, and so that it will be able to contribute to the overall applications, which means this implies that we are in need to invoke the multiple processors, multiple services. It is also required in some of the cases that simultaneous request will be sent to the number of the servers, and services may be implemented as several services processes in separate host computers, so that it will be able to interact as necessary to provide the service to the client process. And that is what it has been shown uh, in this particular figure. Now the servers can also able to replicate or partition itself for the different set of objects on which the services are based. Now the third one is the third architectural model is the proxy server model. A proxy server model, you can say, or you can call it as a cache. You know already what is cache, which is a used to store cache, used to store the recently used data objects that is closer uh, than the objects themselves. So whenever a new object is being received by a computer, it is added to its cache store, replacing some of the existing objects if necessary. And when an object is needed by the client, it processes first the caching service. And the caching service first checks the cache and supplies the object. If the up-to-date copy is available, then it's good. Otherwise, what it do, it tries to find out the updated copy. The server tries to find out the updated copy and provide it to the client. Caches are used extensively in practice also. For example, if you take an example of web browser, which maintains a cache, which is recently visited pages, web pages, and other web resources on the client's local file system. And with the help of HTTP request, it tries to check with the original server that the cache pages which are available are up to date or not. Uh, if it is available, up to date pages are available, it is being displayed. Otherwise, the proxy server provides a shared cache of the web resources for the client machine at a site or across the several sites. So the purpose of the cache or the proxy server is to increase the availability as well as the performance of the services just by reducing the load on the network or on the web servers. So it can play, it can take two roles. One is the that one will be used to access the remote web servers through the firewall, and other which I have already discussed. So this is about the proxy server model. And the next model is the peer process, peer-to-peer model or peer processes. In this architecture, all the processes plays a very similar role. We don't have a server anywhere. The role is to interact cooperatively as the peers to perform the distributed activity without any distinction between the client and the server. So in this model, what is done? Code in the peer process maintains the consistency of the application level resources, and it synchronizes the application level actions whenever it is necessary. So as per this figure, as the figure shows, there are different instances in which in general what happens, and there are n peer of resources processes which are going to interact with each other, and the pattern of communication in between the peer processes depends that what are the application requirements. So in this particular model, we have eliminated the server processes. Thus, we are also going to reduce the inter-process communication delay, which used to happen in between the client and the server. So this is all about the peer processes. Now, as far as its implementation is concerned, it can be implemented as an application process at each site, which relies on the middleware layers to perform the event notification, as well as the group communication to notify that all the application processes are going to change. Now, this peer processes or the peer-to-peer model provides a better interactive response for the different users in the distributed environment in comparison to the service-based architecture. Now, the fundamental model. Now, as we know, we have discussed the architectural model. Now we are discussing the fundamental model. Now, some of the properties are we have seen that in the architectural model, there are certain properties which are very common. And fundamental model is all about concern. It is concerned about with the formal description of these such properties which are common in the architectural model. And depending upon these properties, the fundamental model are classified into three parts, three forms. One is interaction model, second one is failure model, and third one is the security model. Now, every such model which lies under the fundamental model, it is being designed with the different points taken into the consideration. The first point is it must specify all the entities in the system. The second, it should also specify the different ways of communication among the various entities. It should also maintain the characteristic which will affect either by the individual or the collective behavior of the entities. The model should be explicitly mention all the assumptions which has been made about the system under the consideration. Uh, the models also must provide the means of making all such generalization on the basis of the uh, basic assumptions. So what is the interaction model? The interaction model basically uh, used to check the performance of the communication channel. The interaction model normally deals with the interaction features of the distributed system, and various processes which are available uh, has to communicate with each other with the various communication mechanisms. So what they used to do, they send or they receive the messages among each other. So that is why it is based on the performance of the communication channel, because communication channel will be used for the message transfer from one place to another place. Now, various servers which are providing these specific services are the various file servers, or it may be the domain name server, or it may be the network information service provider. There may be many processes which will be communicating with each other for a specific purpose. For example, it may be the video conferencing also. So, meaning thereby the communication is the basic feature of the interactive model. So, as far as the issues are concerned related to the interaction model, it is the related to the performance of the communication channel. So, the first issue is network traffic, which leads in delay in the transmission or the reception. Second issue is related with the bandwidth. So what is bandwidth? Bandwidth deals with the total amount of the information that can be transmitted at a particular given time. If there are various processes which are sharing the same bandwidth, it may lead to delay the program, the transmission as well as the reception. And the third one is jitter. Uh, Jitter, we try to understand in this way that when a series of messages are transmitted, there may be the possibility that there may be a variation in the time taken to send each part of the message. So if it is so, it is called delay. Meaning thereby, if a sound file is being transmitted, there is a variation. If the variation is present in the transmission of the samples, then it may create a noise. So performance of the communication channel is an important issue related with the interactive model. And that is why they are divided into two types. One is synchronous distributed system, and second one is asynchronous distributed system. Synchronous distributed system is difficult to design, but uh, we have certain strong assumptions about that synchronous model. In synchronous model, it is assumed that every process's execution time is known perfectly with the lower bounds as well as the upper bounds. It is also assumed that any message which are transmitted over a channel takes a specific amount of time. So synchronous model of a distributed system can be built, but if and it can be built if the processors are guaranteed with the sufficient processor cycles as well as the network capacity is concerned. But as I told you that it is difficult to design because we must take into the consideration, and that is why the asynchronous, we have to take the consideration about the process speed. We have to take the consideration about the message transmission time. So that leads towards the asynchronous distributed system. The second fundamental model is the failure model. Uh, this failure model must be capable of handling all kinds of failure. It is related with the failure handling. So as far as the distributed system is concerned, there are various processes as well as there are many communication channels, as we know. So the possibility of failure in processes or either in the processes or in the communication channel or in both can occur. So that is why it is divided into three parts: omission failure, arbitrary failure, and the timing failure. So what is the omission failure? Uh, in the process or either in the process or in the communication system. Either the process is going to fail or the communication system is going to fail. Uh, to for performing action, it is supposed to do. If it is happens, it is supposed to recover from that. So this type of failure, that is omission failure, is divided into two parts. The first is process omission failure, and second one is the communication omission failure. So what is process omission failure? Process omission failure is said to occur when the process crashes. What do you mean by crash? Whenever crash used to occur, either the processor halts or does not respond to any request. But other processes which are running on the system, it may be able to detect that there is certain failure or it may not be. It may be also possible that the process sending the request to the failure process have to wait, assuming that the process is slow, and will be waiting. It will be in the waiting state till it is not getting any kind of response. So this type of failure is it is unable to detect. It is very difficult to detect the process crash. So if the process can certainly, it is able to detect that process has been crashed. So that is called fail stop crash. This is the first one, fail stop crash. What happens in this? If there is a process P, if there is process P, which is requesting process Q for a certain service, process P goes into the wait state. If after a certain time, which is after maximum allowable time, that is the timeout process, if there is no response which is being received from Q, then P concludes that it is the fail stop crash which has occurred from at the process Q. Second one is communication omission failure. Communication omission failure, it means uh, there is a loss of message transmission process. If you take an example which is given in this particular figure, process A wants to send a message to the process B, and the transmission of is being done by through a buffer. This is buffer A for the process A. This is buffer B for the process B. So process A sends a data or the information to the buffer A from where it is transmitted to the buffer B, and from buffer B to the process B. This is the normal route. This is a normal procedure. But there is a possibility that there may be a loss of the data in this communication channel. If the data is lost in the buffer A, It is called send omission failure. If the data is not received at buffer B, it is called receive omission failure. So as far as the handling of this failure is concerned, it is very difficult in the distributed system. And there are certain features which are related to these failures. The first is, which we have discussed in the last uh, lecture. First is the tolerating failure, detecting failure, recovery from failure, masking failure, redundancy. All these are the certain points which are associated with that. Tolerating failure, if you take an example of an internet, if it is a big system is big, and you are working on an internet and you have sent a request and the server is not responding, immediately you will be getting a message that uh, server is not responding. So that kind of failure is the tolerating failure. Then detecting failure, if we have proper coding which is embedded with certain error message which are to be executed with respect to certain condition, so that can be done. Because in distributed environment, it is a very challenging task to detect the failure. So what happens if suppose if you take an example, and if a remote server crashes, or remote server has meets the failure, then it is difficult to detect the circumstances at that particular moment of time. So recovery from the failure, the system should be designed in such a manner that if there is any kind of failure which has happened, which is going to interrupt the process of the distributed system, it has to be recovered immediately by implementing many processes. The next one is the masking failure. There are certain failures which after the detection are being hidden. If the data is for example, if you take an example, if a data is to be sent from the process to another, and if it is lost, it can be transmitted again. That is the masking of the failure. And the redundancy, for to tolerate some kinds of failure, we have to do we have to add some redundant components in the system, so that if one is not able to provide, another will be able to provide. Now, if you take an example how it can be recovered, we can have a backup server, or if we want uh, somebody wants the data services is to be given by the server, and the server is not responding at that particular moment of time, so data must be replicated to the various servers, and if there is a fault on one server, immediately some other server will be going to provide that information to the user. So the last model is the security model, and the security model of the distributed system, it can be achieved by first of all, what want to secure, we want to secure the process. So the first model is related with the securing the process of the distributed system. Second one is the securing channels of the distributed system, because these are the two major things which are going to be in failure process. And third one is the protecting the object against the unauthorized access. So we have in the last we have also discussed about some security features, some security challenges which are associated with the confidentiality, integrity, availability. So all these things has to be, all these principles of security must be uh, inherited. It must be incorporated. It must be integrated into the system, so that such kind of mishappening should not happen. If the server is trying to provide any kind of services to anything, any form of the uh, to the client, it should be available. There should not be any denial of the services. There should not be any integrity violation in which the messages which are passing through from one place to another place, there should not be any alteration. The information which is being sent from one to another, there should not be copying of this information. It means there should not be any information leakage. And the last one is the illegitimate uses. unauthorized person should not be allowed to access. So we have to design our system in this model. We always incorporate this all the security features so that the system should remain well maintained.